Question 1 states VOR is sighted at position A, aircraft is at position B. Assuming that the magnetic variation at A is 10 degree west and Bravo, that is aircraft location, is 15 degree west, what is the radial at which aircraft is situated? Now to solve this kind of sum, which is very common in exams by the way, you have to understand two important facts. First, whenever solving a VOR question like this, always variation is applied, variation is applied at the VOR station. Variation is applied at the VOR station. In case you are solving a question which involves NDB, non-directional beacon, NDB ADF question, in that case variation is applied, variation is applied at the aircraft in case of NDB, in case of NDB. Okay, why is this so? So in case of VOR station sends out 360-degree radials in 360 directions, right? So this radials, the direction of these radials are determined at the VOR station. Okay, in case of VOR, the directions of the radials are determined at the VOR station. Okay, in case of NDB, what happens? The non-directional beacon sends out an omnidirectional signal, which is a signal in all 360-degree directions. In case of VOR, that is not the case. In case of VOR, we have one reference signal and another is a variable phase signal which which rotates in 360-degree direction. Okay, whereas the reference signal is oriented towards magnetic north. So this is how VOR radials are determined. But in case of NDB, it sends out one omnidirectional signal. Now aircraft has to do the job to determine from which specific direction is this signal being put out. So the receivers at your aircraft, the sense antenna and the loop antenna will do that job for you, and therefore the direction in case of NDB is determined at aircraft, that is the location where aircraft is situated. In case of VOR, aircraft receivers don't have to do anything. The location where the VOR is situated, and from that location itself, the directions of the radial are determined. Okay, so in case of NDB, I am writing that the NDB sends out an omnidirectional signal. Right. Next point is aircraft receivers will determine the direction of this signal, and from this you will come to know the relative bearing of NDB station with respect to your aircraft. So aircraft receivers will determine the direction of this signal. Okay, so you have to remember this, and therefore in case of NDB, variation is applied at aircraft. Now let's go to a question. In a question it's given that VOR is at 45 degree north, aircraft is at 44 degree north. VOR is at 45 degree north, aircraft is at 44 degree north. This means VOR is situated to the north of your aircraft. And now look at the longitudes. Both are at 10 degree east longitudes, meaning both are located on the same longitude. VOR is directly to the north of your aircraft. So I'm drawing a VOR here. Then I'm drawing aircraft here. You can see by from this drawing that VOR I have drawn to the north of aircraft, to the north of aircraft. Next, very important whenever you draw diagrams to indicate the northerly direction. So this is your northerly direction. Now VOR sends out radials, 360 radials. Now just for illustration, I'm going to draw 4 radials. So one radial will be direct north, another radial direct east, direct south, and this one directly to the west of the VOR. Now our aircraft is to the south of VOR station, and therefore it will be situated on this particular radial, which is radial number 180. Radial radial 180. Okay, so question has asked us what radial is aircraft situated on. So aircraft is situated on radial 180, but this is not a final answer because this 180 number is true number, the direction relative to true north. Now all VOR radials are magnetic in direction. So now the variation which is given in the question, you will have to use that variation and apply it to this true direction and get your magnetic direction. So we all know that variation is the link between your true direction and magnetic direction. Now if your true direction is 180 and variation at VOR station is 10° west. For VOR, take the variation at the VOR location. This 15° west is the variation for your aircraft. Disregard that. So variation is 10° west. Now when variation west, magnetic is best. That means magnetic direction will be more than true direction. So 180 plus 10 is 190. So our final answer will be aircraft is situated on radial. Aircraft is situated on radial 190 magnetic. So you will select the option which has 190 in it. Okay. The delta option 180 is true direction. 190 will be more proper because it is magnetic. So this is how you do the questions of this type. There will be many questions in peak millions. You will also encounter many questions like this in different resources as well. But the technique, the process of solving the questions like this is this only. Same. Let's move on to question number 2 now. Over here, similar question. An RMI indicates aircraft heading. Now RMI, which is a radio magnetic indicator, gives aircraft heading which is magnetic in direction, which is magnetic heading. Now to convert RMI bearings of NDBs and VORs to true bearings, that is from magnetic to true, what will be the correct combination for the application of magnetic variation? Now before we find the answer to this, some basic knowledge about RMI. So what is your RMI full form? It is your radio magnetic indicator. Then on the top of this indicator you will be shown magnetic heading of aircraft. Okay, over here, as aircraft turns, the new magnetic heading will be displayed on the top. Then there are two arrows, two pointers we can say. One is for VOR, another is for NDB. One is for VOR, another is for NDB. Now the VOR pointer, I am coloring it. Okay. So VOR is the colored one and NDB is the pointer which has no color in it. Now the arrowhead of this pointer will indicate QDM, which is magnetic bearing to the VOR station, the track, the bearing that you will have to follow to go directly to your VOR station. The tail will always point towards QDR, which is the magnetic bearing from the VOR station. Indirectly speaking, QDR, by looking at your QDR number, you will come to know the radial at which you are situated, the radial of VOR on which you are situated. So the head tells you about QDM, the tail tells you about QDR. Similarly for NDB, the head of the NDB, this pointer or needle, will give you QDM, that is magnetic bearing directly to the station, and the tail will point towards QDR, that is magnetic bearing from the NDB station. Okay, so head is QDM, tail is QDR, and this is where your magnetic heading is indicated, magnetic heading at which you are flying. So this is your RMI. Now the same after this is your VOR needle, this is your NDB needle. Okay, so like I said in the previous slide, variation in case of VOR is always applied at the VOR station. Variation in case of NDB is always applied at aircraft. So similarly here, the question states that in order to convert RMI bearings. Now what are RMI bearings? Nothing but your QDM, QDR. QDM and QDR are magnetic in direction. The corresponding true bearings are QUJ and QTE. So QUJ is the true bearing to the station. QTE is true bearing from the station. Okay, so this to convert this bearings of RMI, which are magnetic in direction, into corresponding true bearings. So converting magnetic to true, you require variation. Now variation is always applied at the VOR station. Okay, and in case of NDB, you apply VOR, you apply variation, which is at aircraft location. Okay, so the correct option here will be, let's check. Option A states that in case of NDB, you have to apply variation at beacon position, that is the position where NDB is situated. So that is wrong. Bravo also states the same, that in case of NDB, you have to apply variation at the beacon, the variation where NDB is located. So Bravo is also wrong. Charlie states that NDB to be applied at aircraft position, which is correct. And in case of VOR, variation to be applied at beacon position, which is also correct. So option C will be the correct option. Delta states NDB aircraft position right. VOR also aircraft position. That is wrong. In case of VOR, you apply variation which is existing at the VOR station, not your aircraft. So let's go to question number 3. Aircraft is flying on a true track. This aircraft is flying on a true track of 090 towards a VOR station located near the equator, where the variation is 15 degree east. So the location of VOR has a variation of 15 degree east. Now this variation will be useful to us. The variation at aircraft, which is 8 degree east. Now we know that in case of aircraft, uh, the variation is used for NDB sums. For VOR, we always use the variation which is existing at the VOR station. Now, what radial is aircraft situated on? So, similar question, similar to the question number 1, but the method of asking this question is different. So, here we have been told aircraft is flying on a track of 090 towards a VOR. Towards a VOR on a track of 090. So, when you draw this, let's draw the VOR station. This is your north orientation. If this is north, this will be east, right? Now you can fly a track of easterly like this. You can fly a track of easterly and go away from VOR, or you can fly an easterly track and go towards VOR. So there are two possible options. So for more clarity, to select between these two tracks, okay, you have to check the question carefully. It's written towards VOR station. Okay, so we are flying towards VOR station and not away from it. So I'm erasing this part. So now aircraft is over here. So fine, and it is flying towards the VOR station on a track of 090. That is fine. But what radial will the aircraft situated? Okay, on what radial will be the aircraft on? so that you know this will be your 360 radial, this will be your 090 radial of VOR, this will be 180, and this radial will be radial 270. That means aircraft, I'm writing it in words, aircraft flying towards VOR, aircraft is flying towards VOR station, okay, towards VOR by following radial 270 inbound. Okay, now you can fly this radial 270, okay, which is this radial 270. Okay, following this radial 270, you can go outbound, or you can fly on this radial 270 and come inbound. So aircraft is flying towards VOR station. How? By being on radial 270 and tracking and flying on that radial inbound towards the VOR station. Okay, so this is the understanding of the question. Now we have to determine what radial is aircraft situated on. So we have come to know that it is radial 270. But this radial 270 that we are talking about, this radial 270 is true in direction. Okay, it's true in direction. Whatever we find, the first step, the first answer that we find, the number, whatever the number we find first in the first step will always be true. Now you have to apply variation and convert it into magnetic. Okay, so variation at VOR station is 15 degree east, where VOR is located. Okay, so we know that the true directions and magnetic directions are joined by variation. Now variation is 15 east, 15 degree east, and true direction is 270. Now when variation is east, magnetic will be least. That means with variation east, magnetic directions will be less than true directions, right? So 270 minus 15 is equal to 255. So our final answer is aircraft is situated on radial 255, magnetic. All VOR radials are magnetic in direction. So aircraft is situated on radial 255, magnetic, not 270. Okay, so select the option which has 255, which is option A. Okay, so very easy. So you have to be careful about three things here. That first, you are flying towards a VOR station, right? Then for the variation, which is 15 degree east at VOR, okay, don't confuse between the numbers. In exam, under stress, okay, we know it's 15 degree east, but during calculation, we can take it 25, 35. So you have to be very careful during calculations. And the third thing you have to be careful on is disregard the variation at your aircraft location. Okay, it is given only to confuse you. Okay, but it's irrelevant to the question as far as VOR questions are concerned. In NDB, we use aircraft variation. So let's go to question 4 now. Magnetic heading given is 280 degree. VOR radial is 090. What bearing should be selected on OBS in order to centralize VOR needle with a 2 indication? So if you want to get a 2 indication, that means you are flying towards the VOR station, right? And VOR radial is 090. So now let's draw this. There is a VOR station here. There is a north datum. Now VOR radial is 090. Radial 090. Now we can fly this radial 090. Our position will be on this radial 090. Now there are two possible courses of action. We can follow this radial 090 and go outbound. Or we can, by flying on this radial 090, we can fly inbound. We have another option of flying inbound. So it's like a road. okay, on the ground. So we can use that road to go in one direction and also use the same road to come back. So similarly here, this radial 090 can be followed, okay, or can be flown along to go away from the VOR station, or we can follow that and still come towards the VOR station. So in the question, it's given that we want a two indication. Two indication means we are flying towards the VOR. To get a from indication, we will be flying away from the VOR. So radial 090 and a two indication. So in this scenario, what will be your OBS selection? So there are two ways. I will show you both the OBS settings. Now, if you want a two indication, and you want to center the CDI needle, if you want it to be in the center, so your OBS selection should be 270. OBS selection should be 270. That means you're flying on radial 090, that's right, but you're flying inbound. So if you're flying inbound, you will have to put that direction or radial number which when you have overflown VOR, you will be transitioning to. I have explained this concept many times in my previous videos also. So the direct opposite of radial 090 is radial 270. So when this aircraft flies radial 090 inbound, very soon it will overfly this VOR station. When you overfly a VOR station, the two from indication starts flickering. And after overflying, this aircraft will automatically transition from radial 090 towards on to radial 270. Okay, and then it will fly radial 270 and go away from the VOR or outbound from VOR. So the two indication will automatically change into from indication. So if you are flying radial 090 and going inbound, to get two indication, you have to put 270 here. Okay, and this scenario is called normal sensing. In case if you put in your OBS selector, if you put instead of 270 090 setting OBS selection, you will get from indication. You will get from indication, and the needle will be in the center. Why? Because your aircraft is on this radial 090. Okay, right on the radial 090. So the CDI needle will remain in the center, both the cases. But if you put 090, you will get from indication. If you put 270, you get to indication. Okay, now this will be correct. This would have been correct if you're flying this radial 090 and going outbound. But you're flying 090 to go towards the VOR station inbound. So in order to get correct indication, correct meaning normal sensing, that means when the CDI needle goes to the left hand side, you also go to the left hand side. When the CDI needle goes to the right hand side, you also fly towards right hand side to correct that situation. In case you are flying inbound and yet you put OBS setting which is for outbound 090, in that case the CDI working will be reverse sensing. Meaning if CDI goes to the right hand side, you turn your aeroplane left hand side in order to correct that situation. Okay, so always fly with normal sensing. That reduces your workload and you don't have to make many calculations in your mind. So normal sensing is 270 towards. So the correct answer will be, what bearing should be selected on the OBS in order to centralize the needle with a 2 indication? So you will have to take option A, which is 270. So you will have to put a setting of 270 in your OBS in order to get a 2 indication. Go to question 5. Same question, the previous ones. VOR is at position 58 degree north, 73 degree west, and variation at VOR is 32 degree west. Aircraft is at position 56 degree north and 73 degree west, and variation at aircraft is 28 west. The aircraft is on what kind of radial? So here, first things first, VOR is to the north of aircraft and both are at same longitudes. So VOR is directly to the north of aircraft and the variations are given. So you have to consider variation at VOR station. At VOR station, disregard the variation given at your aircraft. So how will the diagram of this question look? This is your VOR. Aircraft will be to the south of VOR, okay, according to the coordinates given. It's also very important to check the coordinates whether you are in the northern hemisphere or southern hemisphere. Accordingly, the diagram will be. Okay, so now here you are in the north. So next the datum, which is a north datum, and when aircraft is to the south of VOR, the radial number will be radial 180. This radial will be radial 360, radial 90, 090, and radial 270. So this radial direct to the south of VOR will be radial 180. But this radial will be 180 true. All of VOR radials must be magnetic in direction. To convert true into magnetic, you will have to take help of variation. You will have to take help of variation. Now variation at VOR is 32 west. Now when variation is west, we all know magnetic will be best, meaning magnetic direction will be more than the true direction. So 180 plus 32 is 212. So aircraft is actually located on radial 212 magnetic. 212 magnetic. So correct option is option B. Let's go to question 6. The principle used in VOR bearing measurement is called what? So this is your VOR station. Okay, VOR sends out two signals. VOR sends out two signals. One is your reference signal. One is your reference signal. Very important. This question can be asked in your SPL YY exam, ATPL YY exam, airline interviews. So VOR sends out two signals. One of them is reference signal oriented to magnetic north. Is fixed in direction. That means it won't rotate. It will stay constant in that direction only. And then another important point, it is frequency modulated signal. Frequency modulated signal. Now the second signal which VOR sends out is your variable signal. What is the meaning of variable? To constantly keep changing. That means this signal, okay, will keep rotating around the VOR. Okay, it will keep rotating around the VOR. So at one moment, let's say it's here, then it will rotate and it will continuously rotate around the VOR. Okay, so this is how variable signal is there. So variable signal is amplitude modulated. Okay, and it is constantly rotating. So we have one signal which is reference signal, another signal which is variable signal. Okay, variable signal. Now the angular difference between this reference signal and variable signal, I will write it here. The angular difference or phase difference between these two signals is nothing but your radial. Is nothing but your radial direction. So let's take this example. This is your reference signal. which is pointing towards magnetic north, right? And then this is your variable signal. We will take a variable signal, which is in this location, in this direction. Now the angular difference between both is 90 degrees. Angular difference between both is 90 degree, or 0, 9 or 0 phase difference. Okay. So this variable phase signal over here, it will be called a bearing of 0, 9 or 0. Okay. And we call this bearing as a radial. We call this bearing as a radial 0, 9 or 0. Similarly, this is your reference signal, and let's take this signal, this variable phase signal. Now the direction angular difference between them is 270. 270. That is the phase difference of bearing between the reference signal and your variable signal. So this variable signal will be termed radial 270. So on and so forth. So this you can do with every radial. Okay. If that phase difference between reference and variable is 10 degree, so you that radial will be called 10 degree. Similarly, radial 20 degree, 30 degree, 40 degree, so on and so forth. When this variable signal makes a complete 360-degree rotation at one point, that is at magnetic north direction, both variable signals both variable signal and the reference signal will coincide. They will coincide. Variable and the reference signal at 360-degree direction, both will coincide. So for that, the phase difference between them will be 0, because both are coinciding. There is no angular difference between them. So that radial will be called 0, 0, 0 degree or 360 degree. So this is the principle of operation of VOR in simple terms. Okay, do read the principle of operation given in the Oxford book in detail. So do read that. But this is the gist of it. Okay. So you have to next one you have to remember is that this principle of operation is called phase comparison. Phase comparison. Because we are comparing the phases of these two signals. Okay, so I have used the word here phase difference. So VOR works on the basis of phase comparison, comparing the phase difference between your reference signal and your variable signal. So the correct answer will be option A. Okay, envelope matching, beat frequency discrimination, difference in depth of modulation. They all are irrelevant, but the delta option, which is difference in depth modulation, that is the principle of operation of ILS, instrument landing system. That is the operation of ILS, principle of operation of ILS. So remember this for your SPL Viva, ATPL Viva and your airline exams. Question 7 again same. A VOR is at position A, which is at 35-degree north, and aircraft is at position B, which is 34-degree north. That means aircraft is to the south of VOR. Now let's look at the longitudes. Both are at 20-degree east. So that means aircraft is directly to the south of VOR. Not southeast, not southwest, direct south of VOR. And both are in the northern hemisphere. Next thing, variation at A, that is variation at VOR is 15-degree west. Okay, so this is what is useful to us. So let's draw the VOR station. This is your VOR station. This is the radial 180. It will be true. This will be your north datum. And your aircraft is to the south of VOR, meaning it is on the radial 180. On radial 180. Now to convert radial 180 true in one to a radial which is magnetic in direction, we will have to take help of variation. True direction is 180. Variation is 15-degree west. So magnetic will be what? So variation west, magnetic west, meaning magnetic direction will be more than true direction. So 180 plus 15 is 195. 180 plus 15 is 195. So that means aircraft is located on radial 195. Option A. Simple question. Let's go to question number 8. A radial is dash bearing dash a VOR ground station. So this is your VOR station, and this VOR station sends out 360 radials in 360-degree direction. Now the job of, let's take this radial 090. The job of any radial is to take aircraft away from the VOR station. Away from the VOR station. So radials necessarily, when you follow a radial, that means you are flying away from the VOR station. You are flying away from the VOR station. Radial is nothing but your radius. So you have a circle. That circle has a center. Okay, this is the center of a circle. Now, in order to draw the circumference, you will have to start from the center of the circle, draw a radius, and then entire circle, right? So what happens? Radius is drawn outwards from the center of the circle. Okay, this center can be imagined or visualized VOR station. So similarly, over here, all the radials will take you when you fly a radial, you will be taken away from the VOR station. In case you want to come towards the VOR station, you will follow the same radial. These radials are nothing but the roads which are in the airspace, right? We have roads on the ground which are visible to us, but the roads or the streets in the airspace are not visible to us because air is invisible. So, but we do have our tracks, our roads in the air. They can be considered radials, right? Those routes. Now, when we can follow one road and go outbound, we can follow the same road and come back, that is inbound. So, when you follow the same radial 090 and come inbound towards VOR, we call it we call it course or bearing, can call it, but most normally it is course. Radial is for outbound and course is for inbound when you are following a particular radial and flying inbound. Okay, so you have to remember these words. Radial necessarily is outbound, and if you want to fly inbound, you can say I am flying radial 090 inbound. Mention the word inbound, okay, for clarity. Or you can say course, of flying a course towards the VOR station. So that is also okay. So based on this, a radial is what? Now all radials, we have solved so many questions so far. All radials are magnetic, right? So a radial is magnetic. So it's magnetic. So let's eliminate option Bravo and option Delta, which talks about relative and true. So that is wrong. So a magnetic bearing, that is magnetic direction, dash a VOR station. It's from a VOR station. So option C is the correct option. Okay, so radials take you away, takes aircraft away from a VOR station, not towards the station. For towards, you will have to use the word course. Okay, that is more proper. So the correct option will be option Charlie. A radial is magnetic bearing from a VOR ground station. Question 9. You are tuned to a VOR station and your needle, CDI needle, is in the center. The instrument reads 140 degrees with from indicated. Relative to the VOR station, the receiver is situated where? So very simple. This is your VOR station. This is your north datum. Okay. And the OBS selector says that you are getting a from indication. And the needle, CDI needle, is in the center. And the OBS setting is 140. 140. Okay, this is your OBS setting. Now 140, this bearing of 140 will be in the southeast sector. This will be your 140 degree direction. If this is your north direction, okay, 140 degree will be in the southeast. 90 degree will be in the directly in the east. 140 will be in the southeast, right? Now your aircraft is situated on this radial 140. 140. Now there are two cases. We don't know whether this aircraft is flying towards the VOR station or away from the VOR station. Okay, all that we know is that needle is in the center with 140 as OBS setting and from indication. Now the needle will be center in two cases. One, in this case, when you put radial 140 and from indication, because radials take you away from a VOR station. You can also get CDI needle in the center with an opposite OBS setting, that is the reciprocal of 140, reciprocal of 140. You can still put, you can be on radial 140. If you're flying outbound, you put this. You are on radial 140, and if you're flying inbound towards the VOR, you will have to put 320, which is 140 plus 180, and in that case, you will get a 2 indication, and the CDI needle will remain in the center if you are flying strictly on this radial 140 center line inbound towards the VOR. So in that case, you get a 2 indication. If you're flying on radial 140 and going outbound, you get from indication. Both cases, the needle remains the same as long as you are on the center line of that radial. So now in what sector are we in? Irrespective of flying outbound or flying inbound, currently aircraft is on radial 140, which is to the southeast of, VOR, southeast sector. So the correct answer will be delta, southeast sector. Okay, let's go to question 10. The VOR to obtain CDI indications in the correct sense. Correct sense means normal working, normal sensing. When tracking towards a VOR on radial 255, what should be the OBS setting? So let's draw VOR. Radial is 255. When you fly this radial 255, the main job of a radial is to take you outbound from a VOR station. Nevertheless, you can follow the same radial 255 and go inbound towards the VOR station. That is possible. So let's draw the opposite of radial 255, which is 15075. Okay. So I will show you two possibilities. If you are flying radial 255 and going outbound, in that case, your OBS settings should be 255 and from indication. Okay, you're going outbound. Now you can fly the same radial 255 and go inbound. In that case, the OBS settings should be to indication 075. If you're flying radial 255 and going inbound towards the VOR, put the setting which is reciprocal of 255, which is 075. So as long as you are going towards the VOR, you will get a 2 indication. If you are on the center line of radial 255, so the CDI will also remain in the center. When you overfly this VOR station, the 2 from flag will start flickering, and when you overfly and go on that side of the VOR station, you will automatically transition from radial 255 to radial 075, and now you will be flying away from the VOR station. In that case, 075 stays the same, but 2 will become from. So this is the normal sensing. This is how it should be. Okay. So the correct option will be 075 with 2, 235, 055, 235. So the correct option will be option number A, 075 with 2 indication. So normal sensing we have covered. We are going towards the VOR and we are following a radial of 255. So the pilot should set on the OBS, it should set 075, going towards the VOR. So very important word, the key word is this, towards VOR or away from VOR. That you have to remember. So this is how you do all the questions. With this, we have come to the end of this lecture. We will do the remaining questions in the next video lecture. So I hope you have understood this 10 questions with explanation that I have solved now. And you are feeling confident to solve similar questions if asked from different resources. The technique, the process, the concept will be the same. So keep practicing these 10 questions. Don't miss my next video lecture in which I have solved the next 10 questions from this.